Hey everyone, in this Back to the Basics tutorial, we're going to be focusing on inheritance and why you should use it. So this is a Back to the Basics tutorial, so this is more or less the fundamentals of what you would learn in a computer science course or programming type course. And these are fundamentals that carry with you well beyond this course and into your development career. So this particular tutorial is going to be in C++, but a lot of the concepts can be carried over between pretty much any object-oriented programming language. So I do have a project open. Some things to note: I will be using Visual Studio Code. If you want to know how to use Visual Studio Code with C++, I recommend you check out a previous tutorial that I recorded. Also, if you haven't seen my tutorial on classes and objects using C++, I definitely recommend that you check it out. A lot of what we do in this particular tutorial will carry on from that previous tutorial, even though that my window is as of now empty. So with that said, we're going to look at some examples. So when it comes to inheritance, it's usually, think of it this way. Let's say that you have an animal, just this generic animal. Now you can subclass each type of animal. So let's say you have a dog. A dog is still a type of animal. A cat is a type of animal. Each of the cat and dog will have their own special attributes, but they'll share attributes as well. So this is kind of the core concept of inheritance, as in you have an animal, it has its own properties, and you're going to inherit those properties in your subclasses, being dog, etc. And you'll be able to use those subclasses, their own properties, as well as the parent properties. And you, in C++ in particular, you can inherit several classes at once. We won't get into that for this particular example, but it is possible. But the kind of core concept of it all is not difficult. It's more or less what I said. So rather than just using the generic animal example or cars example that pretty much everyone gives, I want to change it up a bit. I'm gonna keep it video game oriented. We're gonna be going along with Pokemon. So the example this time around is, you know what? We have Pokemon. Pokemon is a game. It's also a TV show, but we're gonna look at it from the angle of it being a game. And you know what? There's multiple Pokemon games that exist for different video game consoles. So that's going to be kind of our line of inheritance. So we're going to have a console, we're going to have a game, and we're going to have a Pokemon, and we're going to kind of wrap it all together and see how it makes sense. So let's start by creating a console class. So I'm going to say class console, and this class is going to have several different methods and variables. So we're going to have private, and these are going to represent our class variables. In this case, we're only going to have one variable. I'm going to call it name. So the console name, like Game Boy or Nintendo 3DS or Nintendo Switch, something like that. Now I'm going to have a set of methods or functions. So we're going to say public, and I'm going to have a set name. So set console name. Doesn't matter what I call this function, but it should more or less represent what it is we're trying to do. We're going to provide a string of name, so this is a local variable, and we're going to set this member variable. So we're going to say this name is equal to the local variable name. And just like with that setter, we're also going to have a getter. So we're going to say string, we're going to say get console name. We're not going to have a local variable, but we are going to return the member variable. So we have two methods for this. So for this console, and if I wanted to, inside the main, I can say console, and then let's just call it maybe C for console equals, and I'll call it. We'll leave it at that. And I can say C dot set console name. And we can say, you know what, this might be Nintendo 64. I don't think there was a Pokemon game for that, but that's all right. And we'll say cout c.get console name, just for this example to get us running. I'll go ahead and run it. It says I have an error, so let's go ahead and check that error. I didn't add my semicolon on line 22 to close off the class. Let's go ahead and try to run it again. This time around, it printed out Nintendo 64. So it did what we tried to accomplish. Let's go ahead and expand upon this now. So we have our console. Now let's go ahead and worry about our particular games. So game is going to inherit properties of console because games are part of consoles. They're not going to exist separately. So let's go ahead and add to this. So we're going to say class. We're going to call it game, but you know what? It's going to inherit features from console. So I'm going to add a colon here. I'm going to say public console, and let's not forget my semicolon here, but we're going to add our private and public variables and functions. So I'm going to say private. The game is also going to have a name. So that'll be a string. I can go ahead and call it the same thing. Let's say the name might be something like Pokemon Blue, Pokemon Soul Silver, any kind of game name. And the reason why I can name it the same for the private variables between the two is because the private variables are not accessible between classes. So even if you're inheriting, a private variable is not accessible. Only a protected variable or a public variable. So now let's look at the following. So we're going to add some public. So I'm going to say public. Let's go ahead and say the same kind of stuff. We're going to say void. We're going to say set game name. We'll add a local variable here. We'll set it equals name. And we'll kind of do the same thing we saw with the other class with the getter as well. So we'll say string get game name. And we're going to return it. So if I wanted to, let's go ahead and try a few things here. So one, let's go ahead and leave console C. Well, we can leave that there. We're going to create another variable here. We're going to say, let's call it game. We'll call it G. Let's go ahead and say that this game, so g.set game name. Let's go ahead and say that this one is going to be Pokemon Silver. We're just making stuff up. I don't know which games go with which consoles. To be honest, I just know they exist. But we're going to say g.set game name. I'm also able to now say g.set console name because remember we're inheriting features from the parent class being console. So now I'm going to say, you know what, Pokemon Silver. I think this is probably Game Boy Color. But I can't say something like c.set game name because game has no relevance to really console. Console is just a parent class. So for the C variable, I only have access to the set and get console names. So if I wanted to, let's go ahead and try something out. We're going to say cout, and I'm going to say g.get game name. And maybe I'm going to separate it by a slash, or we're going to say g.get console name. And let's run it this time. So it still printed out Nintendo 64 because I still have that in there. But this time around, it printed out the variable data for G, for game. And remember, G is it inherits from console. So let's go ahead and change it up a bit. We're gonna now inherit one more. So this is where we actually get into the specifics of Pokemon. So we're gonna create another class here. So we're gonna say, let's say class Pokemon. This time Pokemon it's not going to inherit directly from console, although it could. We're going to inherit from game, which also inherits from console as well, even though it's not specifically outlined on line 42. So we're inheriting from game. Again, we're going to have our private and public variables. We're not going to have anything protected for this particular example, but we could. So I'm going to say private. This time around, I have maybe a Pokemon ID, and I have a name. So this could be like Pikachu or Bulbasaur or something like that. Let's go ahead and add our public stuff. So again, let's go ahead and have a void. Let's go ahead and set Pokemon name. We're going to have string name. You kind of get the idea here. We haven't introduced anything new yet, but that's good because this is a lot of repetition. This is something that you need when you're learning a new technology. Let's add my semicolon down on line 55 before I forget. Let's go ahead and say string get Pokemon name, and we're going to say return this name. So we're following the trend here. We're not using ID yet, but that's all right. Let's go back into our main function. Let's go ahead and add more to this. Let's go ahead and define a Pokemon. Let's call it Pikachu. Let's go ahead and say Pikachu dot set. And you'll know from my IntelliSense that I now have access to all of the functions that were in the parent classes. So that includes game as well as console. We're going to make use of that. So we're going to say Pikachu dot set Pokemon name. This is going to be Pikachu. We're going to say Pikachu dot maybe set game name. We're going to say Pokemon Blue. And then maybe Pikachu dot set console name, and we'll call this Game Boy. So it's not totally necessary that I'm writing all of this out, but I just wanted to again show you so that way repetition maybe makes it more obvious to you. Let's go ahead and maybe copy this line on line 68, change that to a P, actually Pikachu, and maybe add some more to it. So I'm going to say Pikachu.get Pokemon name, maybe separate that by a slash as well. And it's a long nasty line, but we'll just erase it after this. But I'm going to run it. And this time around inside the logs, I have Pikachu, Pokemon Blue, Game Boy. So far so good. We were able to add methods to each one of these classes that inherits a class, and make use of them inside of our main function. So now let's try to get into constructor methods. So constructor methods is where things get a little interesting when it comes to inheritance, but it's not necessarily complicated. So let's start with the console. So we don't have a constructor. Let's go ahead and say that we want to add one. Let's go ahead and say console. We're going to have a default constructor method. So we're going to say this name. What it's going to do is it's basically going to set our string, so our name. Let's go ahead and say that if we don't specifically call an overloaded constructor method, it's going to say the name is going to be unknown. But then, like I said, we're going to have an overloaded method. So we're going to say console, console, and we're going to provide a name as well. So this one is more valuable to us. And we're going to say name equals this local variable. So it's similar to what we saw in set console name, but this is part of a constructor. So if I wanted to, let's go back down into the main. Instead of saying set console name here on line 71, let's just go ahead and set it inside the constructor. So we're going to say equals, and we're going to say console Nintendo 64. We're going to wipe out line 71, and we should get the same results. And we did. It's still Nintendo 64. So let's expand upon that. So we have our constructors for the console. Now, what do we do for the game? Because this is a little different. How do we call a constructor from a parent class that we've inherited from? So let's start by adding our default. So let's go ahead and say game. In this case, we're going to say this name equals maybe unknown again. So this unknown is representing the game name. So the game is unknown, not necessarily the console name, but we have game. Let's go ahead and say, you know what? Maybe the person has only provided a game name. So we're going to say game. In this case, I'm going to say string name. So this is similar to what we saw in console so far still. So we have name. If I wanted to, let's go ahead and update it before I progress into something new. Let's go ahead and go down into game. We're going to say G equals game, and it's going to be Pokemon Silver. I'll erase it on line 81. So we're declaring the name directly in the constructor. I'm going to run it. Looks good so far. So now how do we set the console name directly from that constructor method? What we can actually do is we can add another overloaded constructor method. And again, it's up to you how many constructor methods you want to define. It's whatever meets your requirements. I tend to think the more the better. The more options you have, the better. But you don't want to get out of hand with it. So we're going to say game. We're going to say string name. So they're going to provide the name. The overloaded command is going to be string console. So if they want to provide an extra string for the console name, and we're going to call the parent the parent constructor method. So we're going to say console, and we're going to pass in one of those variables. So I'm going to provide console. So this console right here matches this console that the user can potentially pass in. If I wanted to, it could also be name, but that doesn't make sense. So we're going to leave it as console. So I'm gonna do this. I'm going to say this name equals name. So what we saw, but by adding this constructor method, it's going to call the constructor method that we have on line 18 through 20. So it's going to call that automatically for us. So let's go ahead and give it a try. So I'm going to scroll down, and what I'm going to do is I'm going to now use the overloaded version. I'm going to say Game Boy Color, and I'm going to wipe out the line on line 85. And I'm going to save it. So you see, we're not doing anything that has to do with the console parent function or the parent class, except for we all call them that get method. But let's go ahead and run it. And you can see so far so good. It still works. So that has to do with calling our parent constructor methods and overloading our constructors. So overloading constructors I went over in the previous tutorial that I wrote about when it comes to classes and objects. So let's expand upon this. Let's finish it off, make it slick and clean. We're going to do the same thing with Pokemon now. So let's go into our Pokemon class. Let's go ahead and add some constructor methods. So I'm going to say Pokemon. I'm going to say int ID, string name. This is going to be our basic form of it, equals ID. This name equals name. We're going to have another version of it. So this is going to be Pokemon. This is going to be int ID, string name. We're also going to be able to provide the game. So this would be the game name. And to follow our logic, we're going to say game. So this is the game constructor. Game, so that matches the game variable that we have the option of passing in. We're going to say this ID equals ID. This ID, not ID, this name equals name. So in this scenario, it's going to call the game constructor. But if we wanted to, we could also call the overloaded game constructor. So we can say another Pokemon constructor here. We can say Pokemon. We can say int ID, string name. We can say string game. And we can also say string console. And we can name them whatever we want as far as these variable names. But in this case, we could say game. And we can call the constructor that has both the game and the console in it. So game and console, because those are the variables that we've passed into this Pokemon constructor. And if I show you, so if we're, to show you what I'm referring to here for this particular constructor method, I scroll up, I'm actually referring to this constructor method. So I can call it from the Pokemon class as well. So let's go ahead and finalize this example. What I can do is I can say this ID equals ID, this name equals name. So we have that. Let's maybe we can fancy it up a bit now. Let's add another method here inside the Pokemon. We're going to say void print. And let's just say cout. We'll say this name. Let's say maybe in brackets we have this get game name, because we don't have access to the game name variable. It's private, remember. We have to use the public methods. But let's go ahead and get the game name from the parent. Let's go ahead and maybe close this bracket and maybe have an opening bracket for another feature here. Let's go ahead and maybe we want to get the console. So we can say this get console name. And again, this is the member function from the parent class. And maybe we say close that bracket just for cleanliness here, and then end L and see what we end up with. So this is just, we're just building a print statement. So let's clean things up. Pikachu now has a constructor method. So we're going to say Pokemon. We're going to say we have an ID. Pikachu is 25. We're going to call it Pikachu is the name. The next item that we can pass in is maybe Pokemon. Let's say Pokemon Red. And we can say this is part of Game Boy. So we're using our kind of mega overloaded constructor method, which has our game constructor and our console constructor. We're gonna erase these 3 lines now. We can keep them in; they're not necessary. Let's just run it for now before I call the print. But I'm gonna say run task. It says Pikachu, Pokemon Red, Game Boy. If I want to now, I can just say Pikachu dot print. Let's go ahead and run it again. And it uses that print line statement. So if I wanted to, let's go ahead and proceed. Let's go ahead and maybe add another Pokemon. Call it Bulbasaur equals Pokemon 1. We're going to say Bulbasaur. We're going to say this is from Pokemon Blue and maybe Game Boy as well. And we'll print it out, Bulbasaur dot print, and then I'll just walk you through what we did one more time. So it looks like it worked again. All right, so let's just rehash what we did because I know it was quite a little bit to take in here. But we came up with the assumption that, you know what, we can come up with kind of objects or pieces of data that kind of it makes sense to inherit properties from other pieces of data. So in this case, I know I gave the example of animals, maybe even people. So maybe, for example, you can have a person as kind of the master parent class, and then maybe each person could be a teacher, football player, an astronaut. So those could be a separate child class that inherits from person. In this case, we have 3 different classes. We have kind of the master is console because that's kind of the top tier. And then we have inside of this console, we have some constructor methods, an overloaded constructor that will set the name of the console as well as getter and setters. Game, so a video game. Video games have to have a console even if it's a computer. So we're inheriting from console. And inside of our methods, we have our constructors as well as overloaded constructors. And some of those actually call the inherited classes constructor. So in this case, console. So if we passed in a string representing console, we could just pass it directly to that parent class. Again, we have our getters and setters, and then Pokemon. While we could inherit from multiple classes, in this case we're inheriting from game, which game automatically inherits from console. And again, we're following that same strategy. We have a bunch of constructors, some of which are overloaded, and we are calling constructors from those parent classes. And through that, it helps us from kind of, reproducing code. Because you don't want to end up copying and pasting code. You want to be as clean and efficient as possible. Because in theory, if you wanted to, you could have Pokemon. Pokemon could have a game variable. It could have a console variable. It could also have game getters and setters and console getters and setters. It just seems inefficient in that sense to have to do that. Because then what if you have a different game scenario where maybe it's not just Pokemon that you're dealing with. Maybe you're also dealing with Legend of Zelda series. You wouldn't have to want to keep copying and pasting code in another sense. You want to be efficient about it. So this is another back to the basics tutorial. This focus was C++. Again, this is inheritance. I recommend you check out my other tutorial on classes and objects. And I do also have a bunch of other back to the basics tutorials, which would be helpful if you are learning how to program. So these are concepts that you will experience throughout your development career. You'll experience them in interview questions. You'll experience them pretty much everywhere. So the best way to master them is to do them. So definitely try to accomplish as many examples as you can.